So today's session is part 2 of 3, titled ArcGIS Maps SDK for JavaScript, App Development with Components. Today we're going to focus on frameworks. I'm Omar. I work as a PE on the Maps SDK for JavaScript, and I'm joined by Max and Nick.
Yep. Hi, everyone. My name is Max. I'm a developer on the Web Components team at Esri.
Hi, I'm Nick. I'm also a developer on the Web Components team at Esri.
And as always, we value your feedback. So if you have any feedback at the end of today's session, please share your thoughts. And again, this is a 3-part series. So the previous session yesterday, if you missed it, we'll have a recording soon. And then there's a 3rd session, and each one of these will build on top of each other. The main focus of today's session is Calcite, the Maps SDK for JavaScript, bundlers, and frameworks. Now, this kind of 3-part series is a bit unique in that we don't typically do this. So the way it flows is, imagine you're quickly prototyping an app using the ArcGIS CDN. And then as your app gets a bit more complex, you start adding more things, requirements keep increasing. You'll want to move maybe from the ArcGIS CDN to using something like a build tool, and then a framework, and then TypeScript for a better developer experience and handling bugs. And then if you're working with the CDN, it's kind of hard to add dependencies and different things from NPM, right? So you can't add React. I mean, you could probably figure it out if you're a hacker, but the focus is NPM, adding dependencies like React, working with React, getting more structure out of your application, and then scaling as your application grows, and with needs like state management and routing. First of all, Calcite. This is Esri's design system. It provides an extensive library of reusable components for designing compelling apps. It provides consistent, customizable, and responsive and accessible UI out of the box. This has been great for ArcGIS Online. As the adoption of Calcite increases across ArcGIS Online, the user experience has become more consistent, which is great for onboarding users. And again, these are web components that are standards-based and framework agnostic, meaning you can work with them in any framework like React, Angular, Vue, Svelte, plain JavaScript if you don't want to use a framework, and just use a build tool. And then it'll be covered in more detail in the 3rd session tomorrow. Now, I'm going to spend not too much time going over Calcite documentation. I know you don't want to read documentation with me all day, so I just want to focus on a few key things. This session is about building an application. So for getting started, you'll want to follow things like how to use the NPM package, loading assets. They come by default from the ArcGIS CDN, but if you want to use local assets, there's instructions for that. And then things like importing styles. And then there are core concepts because these are web components. You'll want to understand what are custom elements, what are slots, shadow DOM, CSS variables for custom theming when you're working with Calcite. And then there's also this whole library of components you can choose from, like an accordion, an action bar. And if you pick any of these components, they all come with an overview describing what is their purpose, what are some best practices when working with them, a sample, as well as code that you can use to help you get started. And then things like accessibility and the API itself, like what properties are provided with that component, the slots, the styles, and so on. Next, we have the ArcGIS Maps SDK for JavaScript. It's a comprehensive and powerful WebGIS mapping library. There are a lot of sessions at this conference about the Maps SDK for good reason. And now, thanks to web components, they're simpler to use. And the way I see the SDK is that it's composed of 3 parts. You have the core JavaScript API, which provides the main functionality, things like the classes, methods, properties, and events that power things like the layers and the components, the visualizations, and so on. And then you have the Maps SDK, which are, again, standards-based web components. They're designed to encapsulate the complex functionality from the core API and the styling from Calcite into small HTML markup chunks, just simple UI. And then we have a lot of documentation, which I'll go over. So we have things like getting started, programming patterns, tutorial samples, API, and component references. So if you go to the developer documentation, you can get started with NPM by just going to the Get Started section, clicking NPM, and we talk about things like managing dependencies, which we'll also cover today, things like installing the components, creating a simple layout, configuring CSS, and then if you work with assets, that's also covered if you want to use local assets instead of the default CDN assets. We also talk about things like React. So at the start of every one of these Get Starteds too, there's a link directly to the JS API resources. If you just want to skip all of this and go straight into, what does a React sample look like? You could go to JS API resources, component samples, pick whatever component package you want to work with, like map components, click samples, and then you can pick Angular, you can use vanilla JavaScript from the ArcGIS CDN, there's React, Vite, Vue, whatever you prefer. And then going back to the developer side, there are programming patterns. I think these are crucial for reading if you're familiar more with the core API and working in JavaScript, because you're generally working with properties. But now because of components, you're HTML first and then JavaScript after. So you'll want to understand the difference between attributes and properties. And attributes are things you can set in HTML, whereas properties are things that you can set in the JavaScript. But if you're working in a framework, what's nice is you can set properties directly on the component, and you can't do that in plain JavaScript. So a lot of these programming patterns are simplified in a framework, but if you want to work in vanilla JavaScript, I would recommend definitely reading these pages about attributes versus properties and watching for changes using mutation observers and event listeners. And as well, we have references. So again, the core API provides the main functionality of the SDK. So if you want to read how those things work, like the feature layer, you can open up that documentation. If you want to work with any of these component packages, you can just pick a component reference, read the description, even play around with the controls. So if I go here and I go top left, I can move the measurement unit or measurement component. I can even change the units of the measurement area measurement 2D. And then you'll see that what's returned is acre based on my control selection, and the provided code snippet that I can copy includes those control selections, which is quite nice. So I don't actually have to code anything to see what it would look like in my own app. I can just play around with it here in the reference, and if I'm happy with it, I can just copy and paste it. And as well, if I collapse the map components reference, you'll see all the other component references, so coding, embeddable, charts. And if I close the component reference entirely, there's the core API reference as well. So all the reference you need for the SDK is in one place, and in a convenient search as well if you want to look up a particular component. And then I'm going to go back. Something you're going to hear a lot today is building apps, the word build. So when you're using the ArcGIS CDN for building an app, I generally call these things like script tag applications. If you're trying to quickly get started, do some prototyping. They don't have a build step involved because we've built the SDK and provided it to you through the ArcGIS CDN. So it's pre-built. You don't have to worry about using a build tool. And you can work in a single HTML file, which can be pretty convenient, but as as your application grows, you might want to have more structure. And then the syntax for including things like modules is require. But then you have building an application, and that, when you build an application, you can work with a bundler like Vite, Parcel, and Webpack, which we'll cover soon. You can use a framework like React, Angular, and Vue, and then these things can help you with routing and state management. And then you get syntax for including modules. So the syntax for including modules is import, not require. So I thought that'd be important to describe before we get any deeper into these topics. And then at yesterday's session, there was one index.html file that was quite interesting. So we're going to take a look at it. So the way a vanilla JavaScript index.html file application might look is you have the head element, and in that head element, you include your dependencies from the ArcGIS CDN, like calcite here, like the core API, and then like the map components. And then you have your HTML, right? There's the calcite shell that contains my whole UI. And then I have all this JavaScript where I'm piecing things together. I'm doing like document.querySelector, document.getElement by ID. I have to keep track of all this stuff myself. And the resulting app, if you remember, if you were at that session, the way it works is you just select the line, and then you get an elevation profile for that hiking trail at a US national park. And then Max and Nick will expand on this app and grow it a little bit. So I'm going to go back to my slides. Next, I'll pass it to Max to talk about bundlers.
Yep. Thank you, Emma. So you have just seen how to get started with an index.html application, but I will expand it further and show you how you can add a bundler to this application. But before I do that, I will go over what are bundlers, what are the benefits, why you might want to use one, and how do you get started with it. So the bundlers are development tooling that help you build your application. But to be more precise, bundlers transform the code that is easiest for developers to write into the code that is most performant in the browser. And this way, you get the best developer experience and the best performance for your users. Besides that, bundlers provide you a series of benefits. The first one, like I mentioned, is a developer experience. With bundlers, you get live reload, where as soon as you make any changes in the code, you're going to get them reflected right away in the browser, and that way you get to see your updates very quickly. Secondly, with bundlers, you get ability to use modern JavaScript features even before they are widely available in the browser. There is also a way to use dependencies with bundlers, which is much simpler than consuming dependencies over CDN, which becomes quite important as your application grows. Thirdly, bundlers have built-in integration with multiple tools, which means you can get started with testing your application and enhancing it quite quickly, in some cases without requiring any configuration at all. And the fourth point is that bundlers do a lot of work for you behind the scenes to optimize the performance. They minify the files, they split your application or join the files together intelligently as appropriate to make sure that application runs as quick as possible, often without requiring any work from you at all. So the first 4 bullet points on this slide, that's the most important capabilities of bundlers that every application benefits from. But as soon as your application grows and you start using frameworks or you like to customize a build process, the build tools allow you to customize any part of the transpilation process to add more integration or change the output type. The build tools have a lot of plugins already written by the community, and you can easily consume those, or you can even write your own custom plugins. I have here examples of the most common build tools in the industry, and Vite is the one that is used the most at Esri. It also has a large community that is still growing very quick, and so that's the one we're going to be talking about today. Because of the large community, it's easy to get answers to Vite questions quickly. The other bundlers are not covered in this session, but the general concepts stay the same, so you should be good too. With Vite, the most important benefit, in my opinion, is that developer experience. And it's just very good, where most of the time the build tool just gets out of your way, makes things happen without requiring any work from you. It's really nice to work with it. Like, the build tools have never been better than they are today, so it's a great time to get started using one. Now, having mentioned what are build tools and bundlers, let me show you an example of how to use Vite, the most popular build tool out there. So, switching back to my VS Code, I have here a small JavaScript demo application, and it was created based on a sample that Omar mentioned in JS API resources. In particular, in JS API resources, we have a sample for map components that is using Vite. That's the one this application was created from. Before I go much further, I would like to mention that all the resources we mentioned today will be shared with you at the end of the presentation, so you will have a convenient way to access everything we mentioned. So let's say we want to start this application to see how it looks like. Whenever you are looking at the build step application, the first thing I do is look at the package.json. A package.json is like a manifest file that describes the application and its capabilities. At the very top, we have some basic metadata about the application. Later, we have the script section and the dependencies. I will cover dependencies in a bit later, but let's talk about scripts. Scripts are kind of like aliases for longer and less memorable shell commands, and the scripts are like actions that you can perform on this package. The very first script I have here is called dev, and it is responsible for starting the development server so that we can see the preview of our application. If you're using VS Code, you can simply hover over the script and press Run Script to get started. Or if you're not using VS Code or you prefer to do things from the terminal, we can also run it from there. So I'm going to open a terminal in this folder, and I will run npm run dev to execute this script. And as soon as I do that, the application starts in the browser here to the side. It looks very much the same as what we had shown you just before with vanilla index.html, except we now use a build tool, and we get the benefits of build tool. Having said that, let me walk you through the code for this application. It's pretty simple. We have an index.html, which is very similar to index.html for non-build applications, with 2 differences. So while you still have a head and a body, there are no styles in the head. The styles will be added by the build tool later. Also, in the body, while we still have HTML here, we don't have any scripts. All the scripts were moved to the file that is mentioned here, which is source/main.js. If I look at that file, source/main.js, the very top, we have an input from the styles file. So that's a unique thing about the bundlers, where you get ability to import styles in the JavaScript instead of doing that in HTML. This way, your styles stay closer to the code they are describing. The styles file at present is pretty simple. I import the styles for calcite, ArcGIS core, map components, and then do basic theming to add a greenish hue to my application. Going back to main.js, here's a new thing that we had to add comparison to index.html application. I'm importing the components my application is using. So in particular, I'm importing from calcite components, the component called shell, navigation, and a few others, as well as from map components, I'm importing the component called ArcGIS Map elevation profile. So by specifying explicitly the components you're using, the build tool knows explicitly what components are needed for this application. And this way, it can produce the most efficient build possible, only including the components that you actually need. This way, the application can run faster and consume fewer kilobytes. If I scroll below that, it will look very similar to an application that is not using a build step, where I will find the references to components in our application, and further down, I will set an event listener. It all looks the same for now, but later on, my coworker will show you how we can simplify this even further. Now, this is a general overview of the application. Let me show you one of the benefits of the build tool looking at this application. If I go to index.html and I want to make some change, let's say I would like to replace US national parks with US national trails. As soon as I hit save, the application updates right away to show me the new values that I specified. So you get a very quick feedback for the changes you make. Now, having mentioned that, let me come back to the point I mentioned about dependencies. So if you look at the package.json, besides the script section, we have this dependency section. And dependencies describe what other packages does my package depend on, what code I'm consuming. The benefit of the build tool is that it's quite easy to consume other packages. And you can go to npmjs.com to search for what packages are available for consumption and what is the most up-to-date version. Also, if you're already using some package and you want to update it, npm.js is a go-to place to see what is the most recent version so that you can know how to update the version. Here's an example of a package.json dependencies section, and we have two kinds of dependencies generally. There are dependencies and dev dependencies. Dependencies are the dependencies that are required for your application to run. These are the things that run in the browser. So that's map components and calcite. They are visible to this user. They need to be included in the browser. We also have dev dependencies. These are, like the name suggests, development time dependencies or build time. You can execute them during the build of your application. You can run them from a command line, but they do not get shipped to your users. This is just for you during development. Now, each of these dependencies has a version number, and this version number usually follows a convention. Let me tell you how this convention works so you can know how to read these numbers. By convention, most NPM packages follow a semantic versioning policy, where the version number consists of three numbers. First is a major version, second is a minor version, and third is a patch version. And this convention is important when you're updating a package, as it helps you know what kind of changes happen to the package. Let's say today you're using calcite 2.0.0, and you wish to update it to 3.0.3. So with this change, you know that the first number of the version changed from 2 to 3. And that indicates there were some major changes. If the major number, the first one, changes, that generally indicates there were breaking changes. And before proceeding to update, you should read the release notes for this application, for this package, to see what are the suggested migration steps. In other cases, when only the second number changes, that usually means minor changes, which indicates there were new features but no breaking changes. When there are new features, it is usually safe to update, but unfortunately, whenever there are new features, there is also a chance of new bugs, so that's something to pay attention to. And finally, we have a third number, that's a patch version, and that just indicates the bug fixes. So usually this is a number that is safest to update and the most desirable to update so that you can get the latest bug fixes included. So if you specify the version number just like this will specify the exact version of that package you wish to use, but often it is desirable to be a bit more flexible. Instead of saying the exact version, you can give NPM a range of versions it can use and let NPM decide what is the best version to use. For example, if you prepend the caret symbol to the version number, that will tell NPM that any changes are accepted, like this version is good, up until the next breaking change. So NPM can use this version or above up to the next breaking change. So that includes all features and all bug fixes. On the other hand, there is also the tilde symbol. And with this symbol, you can say any bug fixes above this are welcome, but I do not want any new features, because that may be a bit more risky. And the benefit of specifying the version number in this way, a bit more wider range, is that NPM is given the freedom to pick the exact version. This comes in play when, for example, you have two packages that use the same shared dependency. Let's imagine we have coding components and map components that both consume calcite. By specifying the calcite version here with a wider range, NPM can pick one version of calcite that satisfies both versions of those dependencies. This way, your application only ships one version of calcite rather than having to include two calcite versions. Now, having mentioned semantic versioning, I need to mention there are two exceptions to this rule. First is that the packages that start with @ArcGIS follow a modified policy, where the first number is usually 4, the second number is a major version, and the third number is a patch version. And what this means is that with the ArcGIS packages, you should generally not use the caret symbol, because that may accidentally break your application when NPM decides to jump to the next breaking version changes. Instead, with ArcGIS packages, prefer to use the tilde symbol. There is also a TypeScript package. If you are using TypeScript, know that TypeScript does not follow semantic versioning, which means any version could have breaking changes. And for every version update, you need to read the release notes to see what are the suggested changes. Now, let's say you built your application with a build tool, and now you would wish to publish it to the world. Well, the process of publishing the application with a build tool is quite similar to not using a build tool. There is just one extra step at the beginning, the rest of the story is the same. And that extra step is the fact that we need to run the command called npm run build. Let me copy this command and go back to my application to execute this command. First, I will stop the development server. To do that, I do Ctrl-C and then paste the command I just copied, npm run build. And that's going to start the build process. So looking at the package.json, you can see that the build command executes the Vite build command. The build generally takes around 20 seconds, but the Vite team is working right now on speeding it up even further. Once the build finishes, you will see a dist folder appear in your package folder, and dist contains the output of the build process. So if I open a dist folder, there are two things here. First is the index.html, which is similar to the index.html you wrote here, except it has been processed by the build tool to add the necessary script and link tags for you. Secondly, there is the assets folder that includes most of the assets required to run your application. So you have the JavaScript files here, and each file, you might notice, it's very much compressed. It's not very readable because it's not meant to be read by developers. This is meant for the browser to be as efficient as possible. And so this folder includes the JavaScript files required for your application, as well as some assets. Now, once you have that application built and you have the dist folder, what you do with the dist folder is totally up to you, but generally very similar to not using a build tool. So the dist folder contains static files that they can be hosted using any static site provider. You can use GitHub Pages, you can use Vercel, other options, or you can use a local web server. You can use Nginx, Microsoft ISS, Apache, and other options. And a fun fact is that the slides you're looking at right now, they're actually built with Vite, and they are hosted on GitHub pages. So as you can see, Vite is quite flexible, and we have a choice of hosting options for our sites. One thing I want to mention is that the assets folder you saw in the dist folder, while it includes the majority of assets, it does not include two things. It does not include the translation files and images for our components. So the map components and the calcite assets are not there. By default, the assets are coming from our CDN. Our CDN is very fast, and we default to getting the assets from our CDN to simplify the build process for you. However, if you have a requirement that your assets must be local, that the application must be fully disconnected from Esri servers, that is totally possible, and we have documentation on how to do that. I have a link here for documentation, and once again, like I mentioned, we're going to share all the links and resources with you at the end of the presentation. With that, I hand it over to my coworker, who is going to talk about further enhancements to our application.
Thank you, Max. I'm going to talk about frameworks now. Vite introduces a build tool, and now we can use frameworks within that build tool to take our application even further. Frameworks make app development easier by providing more structure to the way we write applications. React is the most popular framework, but Angular and Vue are also widely used. And what's awesome now with web components is that they work in most major frameworks out of the box because they're standards-based. So the W3C releases the web components standard, the browsers pick them up, and then the framework authors also pick them up. For this demo, I'm going to talk about React. React is the most popular framework or library. It's also my favorite. It encourages building apps from components, which are reusable building blocks. And it basically creates this idea of a top-down data flow. So you start your app in one big component, and then the data flows down to smaller components. And as it kind of creates a tree of components. And then at each step within the tree, your data model is able to control whether the rest of the tree updates or shows based on your data. It also introduces declarative rendering and events, such as JSX syntax, and that's a mix of JavaScript and markup. They combine that into a JSX file, which makes it so you can look at all of your code at once. You're not flipping between HTML files and JavaScript files. There's also easy state management with React hooks, and React 19 has support for web components out of the box. So I'm going to look at Max's demo, and I'm going to add React to it. First, I'm going to look in the package.json, and you'll see two new packages. There's React and React DOM, which is on version 19. And then we have a dev dependency called Vite plugin React X SWC. Within the vite.config.js, we now use that plugin called React. And that means that now Vite is able to understand React files and JSX files. In our source, you'll notice that app and main.js are now app and main.jsx. That means these are JSX files, and Vite will treat them a little bit differently. The first main difference you'll notice in our application code is now in index.html. We have a lot of, all the markup that Max had in his index.html is now missing. It's just a div with ID equal to root. And then in main.jsx, we're going to use React to bootstrap our app. We're going to look for that root element, and then we're just going to put our React code into there. And that's using the JSX syntax. Within our app file, we have our application code. You'll see that at the top, we're again importing our components. We have a small utility function called round that we'll use. We instantiate some state, so we have distance and elevation. And then we return our markup. So this is all that HTML code that used to be in index.html, and now it's within our JSX file. That's nice, because now I don't have to jump between files. At the top, we have our JavaScript logic. So we have our state, we have our event handler, and then at the bottom, we have what we're rendering back to the user. And we can use what's at the top to control what happens below. If we look at Max's app, you'll notice that it renders with these two little chips down in the bottom. That's because we wait for when we select a trail, the two chips fill up with our information, but we're not controlling whether they show or hide based on whether we've selected a trail or not. With React, it's a lot easier to do something like that. We have our two state objects called distance and elevation, and that's what we'll use to render that information. On our web component, we'll have an on-ArcGIS property change handler, and we'll handle that within our logic. We'll grab that information from the event, and we'll set those two state objects, distance and elevation. When those are set, we go into our JSX code, and we see distance and elevation, and we control the rendering of that calcite chip through conditional rendering, which is a feature in React. So if distance returns a truthy value, we have an AND operator, and we return the calcite chip for distance and the calcite chip for elevation, and within that, we return the distance and elevation state, which is a string. We jump back to our application, and if I select the trail, the two chips will show, and they'll have the information within them. So you can see how that tree works. At the top, we have our state, and the state dictates what gets rendered within our components. So a summary of benefits from React. There's the declarative rendering, which is the markup that we get to do within JSX. It's easy to pass properties to components, and it's also easy to pass event logic. We don't have to do the query selector stuff that we did in HTML. It's all controlled through JSX, and it's easy to consume the web components. We're using our web components right in React, and we just use them the same way we would in HTML. There's no special React code for our components. I want to highlight that difference. So I kind of trimmed down the HTML and JavaScript from the vanilla example, and we have our two chips, and we have our web components, the ArcGIS map and ArcGIS elevation profile, and then we have all the JavaScript on the right. We're using these document query selectors to get those elements, and then we act on those elements from the DOM. So we add an event listener, we check if we found them correctly, and then we update their content when the event fires. In React, we get rid of that HTML. We just have this one div, and then we do all of our React work within that. So now everything is in the JavaScript. We have our logic at the top, we have some state, and then we return the markup below it. And we're able to control what gets rendered in React through the information above. It kind of combines the two concepts in the one file. While React is great, TypeScript can even take us even further. TypeScript is a superset of JavaScript. It adds static types to JavaScript. That means when I define a variable, I can assign a type to it. So if I declare a variable, I can say it's a number or a string, and that improves the developer experience and code quality. If I write a function, I can say what that function expects from the user. And that's really nice. So if I write a function and I pass it off to Max, he knows what he needs to pass to the function for it to work correctly. And the IDEs will be able to handle those types and give validation errors to kind of help the developer as they write. And I'll show that in a bit. And what's great is that the Maps SDK components and calcite components come with TypeScript definitions right out of the box. So I'm going to jump to a TypeScript demo. And I'm just going to add TypeScript to the same app. Just going to close out of my previous app. Now we're in TypeScript. We'll look at package.json again, and now you'll see the TypeScript dependency. Now within our source files, we have TSX files instead of JavaScript X files, JSX files. That just means that they have TypeScript within them as well. In our app.tsx file, you'll see that we now have these type annotations associated with them. So our round function, which was just a little utility function, now says it expects a number. So if I was to use round and pass it a string, I'll get a validation error from TypeScript within the IDE. So it's going to say, argument of type string is not assignable to the parameter of type number. If I give it a number, it'll work OK. There's a number of type annotations throughout this page, and I don't want to go too deeply into how they work. But I do want to show some other features of calcite. So if I start, not calcite, TypeScript. But if I start typing a calcite component, you'll see all this autocomplete. So TypeScript adds all the different calcite tags into my IDE with autocompletion. That's pretty nice. And what's also really cool is that we can type the event we get back from the JavaScript API. So when we handle the elevation profile change, we type the event. And I noticed that we're using the statistics object to find elevation gain and max distance. What if I want to know what else is available on statistics? I can type statistics into my browser. I can browse then what attributes are on that statistics object. And I can look at this and I can see Okay, there's also a max elevation property. And that might be nice to the user to when they're looking at their trails to know if they have elevation sickness, maybe they shouldn't do a very high trail. So let's add this to our application. I can do if statistics.max elevation. I can get the elevation. And then I'll have to instantiate a new state. So I'm going to come up here, and I'm going to say const max elevation, set max elevation equal to react.use state, string or undefined. And then I'm going to set it as undefined, and it's my initial value. Back in my event logic, I'm going to set that state to max elevation. And it looks like I get a validation error. I'm trying to set it with a number, but actually I need to pass a string. I want to include the units. So I'm going to say max elevation, and then I'm going to include the units, event.target.effective units.max elevation. And then in my code, I'm going to conditionally render that chip along with my other chips. So I'm going to say if max elevation, I'm going to return a calcite chip, and I can give it, close that up, and then I'll give it the max elevation. And again, I'm getting a validation error, and this is a feature of TypeScript. It's going to say that I'm missing a label. So I'll just make sure I include a label, max elevation. I'll also give it an icon equal to maximum graph. And everything looks good. I don't see any more validation errors, so I'm going to jump back to my application. I'm going to select a trail. And you'll see the additional chip here that the max elevation is 7,000 feet. And in fact, I've done this hike before. And it was at the end of a day I've actually hiked up from the valley, back down. And I remember adding this hike and thinking it was about 4 miles and I can do it. But when I remember doing it, it was actually really, really steep. And while it was a pretty hike, my knees hurt pretty bad at the end of the day. And I think I could have skipped this one. So what would really be helpful is if I could render a scene next to this and actually see the elevation change in 3D. And with React, that's really easy. I can just include a new component that is a mini-map, and I'll make that mini-map 3D. So I'm going to cheat a little bit here, and I'm going to use some code snippets. I'm going to add some imports. Oops. And in that component, I'm creating a new React component called minimap, and I'm going to pass it a selected graphic. That graphic comes back from the elevation profile. I'm going to create graphics. I'm going to create a small div called minimap. I'm going to give it a position of absolute so it pulls off of the page. And I'm going to use the ArcGIS scene component. Again, this is a ArcGIS map component, and I'm using it right inside of React. I'm able to pass complex objects straight to the component, and I can use this within my application. I'll have to create a new state object for that selected graphic. So again, I'm going to cheat and use a code completion. I keep missing that one. And I'm going to create a selected graphic and a set selected graphic state. And inside of that state, I'm going to use an Esri graphic. Inside of my event handler, I'm going to set the selected graphic. And then inside of my calcite shell, I'll render that React minimap component. And then again, I'm getting a TypeScript there, which means I just need to pass that selected graphic. And then if I let's say it is guaranteed to be there. Oh, actually, we're going to use conditional rendering. So selected graphic. And we just want to make sure that selected graphic is defined when we render it. Then if I jump back to my application, I click on that same trail. We get the minimap. It zooms straight to my trail. And then as I look at it, I can remember how steep it was that day. And yeah, hikers beware. I'm going to jump back to the presentation here. So a summary of benefits from TypeScript. There's an improved developer experience because we have that contract between the types and what we provide, the functions and variables. That's through static types. We have IntelliSense, so I get all the auto-completion that I showed you. We get error checking, so if I'm missing something, it'll tell me what I'm missing. And that gives us so much more confidence in the code we write. I also want to tell you about some framework-specific component wrappers that we have. While React 19 supports web components right out of the box, React 18 doesn't. So we really encourage you to use React 19, but if you need to use React 18, we do have packages for you. They're on NPM at ArcGIS Map Components React. Calcite also has a React 18 wrapper at Esri Calcite Components React. We also want to acknowledge that there's other frameworks out there. Angular and Vue have support for web components. We know they're very popular. We have a Getting Started with Angular doc, which we have linked in these slides, which we'll link to you at the end of this presentation. We also have a Vue sample application, and we have the JS API resources, which have a bunch of other samples inside of it. And Omar showed that a little bit earlier. Finally, we have a couple more sessions this week. Later, we have a Vite deep dive. So if what Max showed you was really exciting, totally encourage you to come see this session. That's from 4 to 5 today. And then we have the next session in this series called App Development with Web Components Part 3. And we're going to talk more about user experience and Calcite. And that's tomorrow from 1 to 2 p.m. And with that, we'll open it up to questions. The QR code here will take you to the slides and the resources we showed today.
Nick, do you want to walk around with the mic?
Sure. Yeah, just raise your hand if you have a question, and I'll come find you.
Hey, my question is just if you guys have any samples available for creating a web component by chance, and if I'd like to incorporate the reference element thing that you guys are doing in my components.
Don't know.
And I'll repeat the question. It was just a question about if we have any samples for creating our own web components.
Yes.
Okay, that's a good question. So web components is not a technology from Esri. It's a general technology from the browsers, which means you don't need to follow Esri-specific resources. The general documentation of web components in the web will also work for you and will work with any components we build. So for example, the good resource to follow is MDN, which is an official Mozilla documentation. It's very comprehensive. And if I search for MDN web components, I will find this page on web components. They go through all the parts of building a web component, from the very basics to more advanced. They do not use any framework, and they do not use TypeScript, so it's a very basic example, but you can always expand it further. I would recommend, even if you're using a framework, to go through these basic steps of no framework web components, learn the basics, and then you can search for web component frameworks if you're looking for that. Yeah. And for reference element, so at present, the reference element is useful if you want to display your component outside of the ArcGIS map, outside of ArcGIS scene. For other map components, if it's rendered inside the ArcGIS map, it finds its parent automatically. And we do not provide a utility for this logic for your components to use, but you're free to replicate this in your own components, where you can search for nearest parent component like ArcGIS map, ArcGIS scene, and if it is not there, accept the reference element attribute and use it to find an element on a page. Does that answer the question? Yep, thank you.
Do you have a question?
I have a two-part question. One, can you throw that live code that you did into the GitHub repo? Because that was really fast.
Yeah.
And then two, okay, I didn't see it on there. And then two, for the reference element, if we're using React, do we need to do like a use ref instead of that reference element? Or like is it exactly the same as the vanilla JavaScript? Like how does that work?
Yep, good questions. So the first one was about the demo, whether the demos are available, correct? Yes. So all the demos we mentioned today, they will be shared with you at the end of the presentation. So, and by the end, I mean the QR code here on your screen. That goes to the GitHub repository with the demos folder. And here you can see an incremental demo for each part we mentioned today. So you can go through, see how our application was built step by step. Now for the second part of your question, so the reference element works the same regardless of what framework you're using. In general, most things about web components work the same regardless of the framework. The reference element property, it accepts a reference to the HTML element itself, or a string that is an ID, or a string that is like a query selector. So there's three options. And if you're using React, you're free to use useRef and pass that as a value. But one note is that useRef does not re-render your component. So if a ref wasn't assigned on time, it may never get assigned because React will not know to re-render your component. The other option is to use an ID that gives the map component responsibility for finding its parent. But with IDs, you need to make sure that ID is unique on the page. So you don't want multiple elements with the same ID on the page. That is going to confuse it. Okay.
I think I saw a question. Okay.
So I'm going to put the QR code back on the screen.
Yep, go ahead.
Yes, sir.
I have it here.
Yes.
Hi. Do you have any examples or recommendations on how to work with custom pop-up content in React?
Do we have it?
Not that I know of. It's probably something we can talk about at the showcase afterwards.
Yep, come over to us at the showcase. We can show you.
Sir?
Thanks. Hey guys, one quick question about components. Are they fully featured? Like, if there is a component available, should I assume that it has the same features as like its analog widget would be, or do I have to, you know, as I'm migrating, should I be tracking what features are available within a component? And then also, I just wanted to shout out, I love the programming patterns pages. Are there any plans to expand on any of that and add more sort of best practices for what you guys see?
Yeah, good question. Yeah, good question. So the best practices page will be continuously expanded more, and we're just beginning the transition to components. As we go forward and forward, more and more of our samples will be focused on components, and we will be publishing more component best practices for you. And the first question was, Nick, repeat for me.
I think that was it. Was that it?
Are the components fully featured?
Oh yeah, great question. So the first question was, is the API for components any features, capabilities between the components and widgets compatible? And answer yes. All of the features that you have in widgets are going to be available in components. So you can use the components today, migrate your application steadily. Going forward, we will prioritize adding features to components only, and the widgets will be in maintenance mode. So if you have a capability, please continue migrating your application to components. If you want us to add more features, generally we will be adding features to components only. So that's the part where you will see more new features added from the component side only.
All right, I think we have one more question here.
Hi. Are the references to the map elements able to be passed to other components that are being imported into like a larger component?
So you're asking whether the references will be passed down to other components?
Yes.
So when map components search for the referenced element, they search anywhere on the page within this DOM tree. If you display our component inside a shadow root, they will look inside the shadow root. If you're using React components, it's all rendered, all React components are rendered as part of a single DOM tree. So even though in React there's a hierarchy of parents, children, for our components, it's all part of a single tree. They can find their way around there, no problems. So if you have an ID for a reference element or HTML reference to a reference element, you can pass it down your tree, and that will be not a problem.
Questions over here? Excuse me.
Hi, do you have any examples of using the Maps SDK with more complex state managers like Redux or TanStack Query?
Yeah, the question was whether we have examples of using map components with state management libraries like Redux and others. We don't have examples for that yet, but if you see examples online of using Redux, that will be generally close to the pattern you will use with web components, because we're trying our web components to not create a different coding pattern, but whatever the coding pattern is already recommended by the frameworks, that should work with our components. So I would encourage you to look at the documentation for React, Redux, or other state management libraries and see what is the recommendation there, and that should generally work with our components. If not, you can leave a post on the Esri community and we can give you a more specific recommendation.
Any more? There we go.
And then, in the meantime, do you want to show?
Oh, yes. Yeah. After. Yes.
Thanks for the presentation. I was wondering if you're choosing the different frameworks, do you guys have any criteria that you're using to like evaluate Angular versus React, or any of the other additional frameworks that are providing additional things like routing? Do you have those criteria, or do you have recommendations for evaluating those?
Okay, so the question was whether we have criteria for recommending frameworks. The first, I want to answer that Esri themselves, we do not use frameworks in our library. We want our library to work with any framework out there. That's why it's built as a web component. And then on your site, you can use them in any framework you wish. As far as which framework specific to use, again, we do not know the specifics of your application, so we cannot recommend. All we can say is that React and Angular are very popular among our users, and that's why we provide samples for you ready for use with React and Angular. But our components will also work in Svelte, Vue, and others.
Do I see any other hands? Anyone see anyone?
Okay, if you have any more questions, we are at Showcase at the web development area, so we'll be there tomorrow and today. So come over and ask us questions. And with that, I would like to encourage you all to leave feedback, because your feedback is informing us what sessions we present next year. This is a new pattern for us to have a 3-series sessions. If you like it, please leave us feedback about that. And having said that, I would encourage you to also connect with us on social to learn about the Dev Summit for next year. And that's it. Thank you for coming.